Hi everyone, this is Mrs. Pagan, and in today's lesson we will continue to talk about using properties of exponents. These are level C types problems, so we are going to move at a quicker pace, but making sure that we understand these more difficult problems. Alright, let's look at example number 1. In example number 1, what you're going to notice is that we have two fractions. Technically, I could just go ahead and combine those two fractions by doing a simple division line. Okay, so that doesn't scare me very much. Now, what I do tend to do is work with the top first, the bottom first, and then connect them. So, negative 3 times 7, those are two numbers, multiply it to negative 21. I have 1m here and 4 more here, so that's a combination of 5. I'm adding the exponents. I have 1t here and 2 more here, and I have a combination of 3, so it's t to the third. Divided by 2 times 9 is 18, and I have m to the third times t. Now I can go ahead and simplify as I choose. So looking at the numbers, negative 21 and 18, it seems like they have a number in common. And the number that they have in common is, do they have a number in common? 3. So we can go ahead and simplify negative 21 by dividing it by 3, and we get a negative 7. And I'm just going to do that so I don't forget. And 18 divided by 3 is the number 6. So now those are simplified, and we can go ahead and subtract the exponents of 5 and 3 since they have the same base and it's division, and we get m to the second power. And we can go ahead and do the same thing for the t's, subtract 3 minus 1 and get t to the second power. Since none of the exponents are negative, I don't have to move it. Remember that a negative number is not the same thing as a negative exponent. So therefore, this right here is our final answer. Alright, let's move on to example number 2. In example number 2, we once again have two exponents, but I'm not going to connect them here because I notice that there's a power of 2 that I have to handle first before I can combine them. So I'm going to rewrite the first one without parentheses because it's really not necessary. And the second one, I'm going to go ahead and distribute. So h to the negative 4 power, because negative 2 times 2 is negative 4. I'm going to go ahead and do 5 to the second power because I have to distribute the power to the 5 as well as the r to the second power. Now that there's no parentheses, I can go ahead and combine these and put my multiplication to the top and the denominator. Alright, now let's go ahead and combine like terms. We have the number 2 by itself on top. We have two bases that are the same with h's, so we can go ahead and add these exponents because it's multiplication. So 2 plus negative 4 is h to the negative 2 power. We have 5 squared, well that's 25, and we have two of the same bases. We have 3 r's here and 2 more here, so that's r to the 5th power. Now everything looks good except for h to the negative 2 needs to come down because it's a negative exponent. So we're going to go ahead and move it down. 2 will stay there because 2 is positive, and the exponent is positive at least. And then we have h to the second power and r to the 5th power. Notice that when I was writing these, I made sure that h came first and r came second because that's how it goes in the alphabet. Alright, let's go on to example number 3. Example number 3, I can actually combine these, but I'm going to take care of this this parenthesis with the cube first before I do that. So I'm going to just write d to the times s to the negative 2 divided by 2 to the third power, distributing the power of 3, s to the third power, d to the third power, times 4 over d squared. Now there are no parentheses. I can go ahead and combine these two fractions, giving the multiplication to the top and bottom. And that way I can work with the top first and then the bottom and then combine. So on top, I just see the number 4. Then I see d. Then I see s to the negative 2 power, which I'm going to have to move down. I am fully aware of that. Now 2 to the third power is 2 times 2 times 3, which is 8. Then we have d, but we have two base d's, and since it's multiplying these two right here, I'm going to go ahead and add the exponents, d to the 5th times s to the third power. Now remember that we just talked about how this s to the negative 2 power has to come down because it's a negative exponent, so I'm going to go ahead and do that. 4d over 8d to the fifth and s to the third times s to the second. Now, I see a lot of things that we have, so I'm going to go ahead and simplify. 4 divided by 8 simplifies to 1 over 2. Now, I can subtract d to the 1 minus d to the fifth, and I get d to the negative 4, which then I know I have to move down. So I'm going to go ahead and use my eraser, and I'm going to move it down right away and make it a positive 4. Then I have 3 s's here and 2 more, and that's s to the fifth power, and there is our final answer. Alright, well done. Now we have 2 more examples, so you're doing a great job as we go through these more difficult examples. So once again, there's parentheses. Let's deal with those parentheses first, not let them scare us. So I'm going to go ahead and just do distribute x to the negative 6 power, negative 2 times 3. Then there's 3x squared in the denominator times 2 over x to the fifth. And since there are no more fractions, or parentheses, I'm sorry, I can go ahead and combine that fraction and put those multiplications. Now, I'm going to go ahead and circle this because I know I have to move it down because it's a negative exponent. Nothing else really has to move, so I'll keep the 2 on top. But then there's 3, x to the second, x to the fifth, but I'm going to go ahead and move x to the negative 6 to the denominator. Oh, I made a mistake. I hope you caught it. It's not supposed to be negative 6 anymore. It's supposed to be x to the 6th. Alright, now I do notice that there's a lot of the same base, which is all x's here. So I'm going to go ahead and put the 2, put the 3. They're simplified already. But I need to add these exponents. So I need to add 2 plus 5, which is 7, plus another 6 is x to the 13th. And that is our final answer. Alright, we're heading into our last example. Okay, so let's kind of make this a little bit larger. Looking at the last example, I can see that there's a lot of parentheses, so I want to just take my time on this. So first I have a outside parenthesis, and it's 3, and then I'm going to go ahead and figure out this little one. So the power of 2 only goes to the 5 and the x to the 4th, so I'm going to write that as 5 squared times x to the 8th power, because 4 times 2 is 8, all over x, times 1 over 5 x to the negative 3 power. Now, technically everything is okay. There's nothing in parentheses to a power, so I can actually get rid of these parentheses, and I can combine this fraction like that. Alright, now we can go ahead and simplify. We have 3 times 5 squared. Well, I know 5 squared is 25, times 3 is 75, x to the 8th in the numerator. In the denominator, we have 5, that's the number. Then we have x to the 1 power and x to the negative 3 power. So we have to add those exponents. And 1 plus negative 3 is x to the negative 2 power. Now, hopefully you're going, wait. There's a negative exponent. It has to be moved. So we're going to go ahead and change its location to the top. And we end up getting 75 x to the 8th times x to the 2nd over 5. Now there's one more thing we can do. First, we can simplify 75 divided by 5. And I believe that is 15. And we can combine these x's right here and get x to the 10th power. Alright, and that is our final answer. Now, I just want to say that you guys did an excellent job. This is a very tough subject, but you finished it. So go ahead to the table to work on some in-class practice with these more challenging problems using properties of exponents. Well done.